In this video, I will talk about something that everyone enjoys doing that has a 3D printer, which is printing things to organize all the little pieces that we use to build other things again. We'll try to build something to organize this. So I have all these cables which I use on my different prototypes that I'm building. I have multiple of these breadboards where I'm trying things out. This box has always been a mess and I'm going to do something about it today. The basic idea that I have is this. The idea is to print a box that is shaped like a comb at the end, and we can just insert them like this. And the box needs to be more or less the length of the cable, and we can just slide them in and keep them without getting tangled, and organize them by length and color, or print different boxes with different lengths. We'll see. I'll start with the shortest one because this will take the least amount to print. If we have just this box and we leave gaps like this on the sides, just try to imagine it like this. This will take ages to print because it will have to restart, recheck, and so on, and print the fans, and they will break off pretty easily because this joint here will be on a layer boundary, so it will just break off. And I'm going to challenge myself to come up with maybe a snap fit, so we can print it as one piece and then just lift it up and clip it together so it's a fast print and a durable model at the end that requires no other parts. Yeah, let's see how this goes. Before I start designing this, I have to think about a few things. So first of all, to get this mechanism to fold things up, my idea is to design it in the following way. That is idea number one. That if this is the floor of the box, here this bottom part, it needs to have a 45-degree angle, maybe a millimeter or half a millimeter gap with a single layer, and then it needs to have this 45-degree angle. So this will be exactly the joint where it will be folding. So it will fold inside here. So I have the same thing, the gap, the angles again, and then this piece, and this folds up from the other direction. So just folds up. This is the first idea. So this is how it looks like in detail. Now, so designing this will be fairly easy. I have to just make up something that looks like this. The side walls will be printed standing upwards, so there's going to be a fast print, just going with 2 travel moves for each layer, and those will be printed lying down, so those will be those the pins on the side that fold upwards. And I need to find a way to make joints here, so if I make this a little bit wider on those sides, leave a gap here, design a little nose on this end, fold it up, it should just clip in, and it should not have any tension on any layer boundaries. AT here. Let's see. It's going to go wrong in any case. So this is Blender, and I'm just gonna start by modeling the bottom main part and the sides. So I'm gonna add a plane with a radius of 40 millimeters and size it along the y-axis by 0.5, so it's 40 times 80. So this is where the cables will be stretched along. Then I'm going to select this edge, move it to the center, grab it along the y-axis by 20, oops, minus 20. And because I'm lazy, I'm going to add a modifier, the mirror modifier, along the x and the y-axis, and then I'm going to move those to the center as well. So grab it with G along the, I'm going to hit X for x-axis, and then type in the number 40 to move it by 40 millimeters, and then it's exactly here. So if I take this edge, hit E and hit enter, then grab it along the y-axis, hit Y again by 2 millimeters. Oops, grab it along the y-axis by -2 millimeters. I get this wall bit, grab this edge, extract it by 2 millimeters. Oops. X-axis. I'm going to take this, extract this face, rotate the view to the front view and move it up along the Z-axis for 20 millimeters. So this is the walls, the edge selector, turn it the front view, grab it along the Z-axis by -2 millimeters, so I have this 45-degree angle, extrude it along the X-axis by 1 millimeter, I have no idea. Extract it again along the X-axis by 2 millimeters, and then grab it along the Z-axis by 2, so at the other side. This is 20 millimeters high, so extract it again and grab it by 20 millimeters this side. So we have this. This will be the part that folds up, so extract the edge, grab it along the Z-axis by -2 millimeters to go down. This needs a thickness of 0.2 millimeters because I prefer printing at a level height of 0.2 millimeters, so I'm going to extract it again by 2 millimeters. Grab that -0.2. I have to activate the vertex snap here at the bottom. X here. Extract, grab on the X-axis, extract, grab on the X-axis again. So we finally have the bottom layer. Select this, extrude it, grab Y -2 millimeters. I have those sides that will connect somewhere around here. So I'm going to cut this 2 times to get this face, extrude it by 3 millimeters. I don't want to print with supports, so I'm going to grab those two, this edge, I'm going to grab it along the Z-axis by 3 millimeters, so I have a 45 angle degree, which you can print with as an overhang without any supports. I have to cut it 2 times, so I get 3 elements, so this edge here is 1 millimeter in length. What you can do is here on the right hand side in this menu, if you scroll down, you can select edge length and you can see the length of a selected edge. So this one's 1 millimeter, so this is the part that will be sticking out of the side here. If I size this along the y-axis by 0.5, we'll have 1 millimeter. Cut it again, size it along y-axis to get this. So I'm going to grab this along the x-axis and pull it up in here. 0.5 millimeter, so by 0.5. So we get this fin here. This looks much better. Cut this face here. Size it along this, size along the z-axis and give it a size of 0, so they're exactly horizontal. Extrude this by -0.5 millimeter. Just grab this edge and grab it up by 0.5 millimeter. We get another angle here. Let's go to here and here. Just make something like this. This should be able to squeeze through something we have to add here. So this is right in the center of those 20 millimeters. And then I'm going to remove those parts with a boolean modifier. You will see that. Let's close all the holes. So this is basically the model. If we want longer sizes, we'll just select everything that's on the right hand side here. So go on to front mode, vertex selection, hit Z, so we can select everything that we see from this angle, hit Z again, and then we can just go grab X and change the length for different sizes, which we can try later. Now to the fins. Let's see how thick is the cable. 1.8 is more like it. Going to top view, add a cube, and give it a radius of 0.9. If we select the edge info length, we will see it has an edge length of 1.8 millimeters. Grab this bit to be outside of the object, and now we're going to grab this to go all the way here, and then grab x 1.8 because I like symmetry to here. Duplicate it, grab y 1.8, grab y 1.8, duplicate it again, grab this by 9, so this is centered now. If we add one more, we have 1, 2, 3, 4, 5 slots. Select this side of the box, grab it up to this point, and then grab y minus 0.9 to get the symmetry again. Now this doesn't need to get to mirror modifier because this object already has. So go into the front view, select everything, size it along the z-axis by a factor of 2, grab it a bit, and move it just that none of those lines of this object are exactly on the same height or location as lines of the object you want to cut with. Which means, let's give this a name, bool.cut. Give this object a modifier, which is not the mirror modifier, but the boolean modifier. Move it upwards in the hierarchy. The operation type is difference. Select the boolean cut object, and we will see when we move this to a different layer, we'll have those fins. Now what's missing now is the hole on the side to cut this out. So I want to put this into exactly the thirds, so I'm just going to select those and then cut it. Let Blender do the math and then remove the outside edges again. Then top view, move it here to the bottom, select the bottom vertices, grab Y here, here. So if we remember correctly, we saved 0.5 millimeter here, so let's give it more than that. So let's think for a second. If we just move by 0.5 millimeter here and 1.5, 0.5 millimeter here, this will be an exact fit, but we don't want that. And also we want to give it some wiggle room, so we're gonna size it. No, let's select not around 3D cursor. The pivot or pivot point should be around the median point. Size along the X by 1.5. That should do it. So it should be a bit flexible. Let's hope. Let's see what happens. Well, the nozzle is going to be 0.4, so we can give this, grab y.1 millimeter here and y minus 0.1 millimeter here, so we have exactly one perimeter here. Let's see what happens. So just grab this up a bit, extrude, grab it down. We have this block here. We're going to call this bool cut clamp snap. Move it to a different layer. Select this again. Add a modifier. Boolean difference snap. And if we're lucky and have the right ordering, this should work. So this should actually work in theory. Let's save it. Let's select this object and export it. We have the right object. Now we can print this. Now I'm not entirely happy with it yet. These edges here, for example, tend to break easily, so I'm going to Let's look at the preview, and then the preview looks like this. This is going to break here. So let's fix it in the model. And this has now 2 parameters which should give it more strength. So let's print. So about 1.5 hours later, and exactly 3 attempts, I managed to print this. Let's see if it actually works out as planned. First thing I noticed is that the holes here are not entirely perfect, which is due to the nature of my printer. And I have to clean those up a little bit first. Let's see if this works. No. Have to wiggle it open a bit, and then it should work. Okay, this side is good. After about a couple of minutes, it actually fit. So it looks like this. Let's try it out. This seems to work. I will print a couple more of those, and this should in the end look a lot better than this. Please let me know in the comments what you think about this. If you're not subscribing, please hit subscribe. See you soon.